Good evening, dear participant, and I hope that all the things are very fine. And sorry, yesterday we have to postpone the session, and today everything is going well. Due to technical problem, we have to postpone. Yes, I can wait few student, few participant, and as soon as I got the response from your side, we will start the session. Great. So first of all, once again, good evening, all of you, and please put your name with your country name, and if possible, your subject also, whether you are a beginner or you need advanced level. If you need the very basic concept also along with this lecture, then I can manage accordingly, and we will try to finish within maximum 2 hours. Okay, so if you can put your name in the chat box, you along with your country. Yes, Siddiqur Rahman from Malaysia. Nice to meet you. Very good. Very nice, Siddiqur. Ashwarya Seni, you are from India, mathematics. Great. Also, please let me know if I am perfect audible. I think some of the participants will join very soon, because yesterday, due to some technical issue, we have to postpone, because actually the session was organized for Sunday. Okay, so yes. I have prepared everything for you, and the script file is ready, PPT is also ready, and at the end you can submit your feedback form. Feedback link will be provided to you, where you can submit your feedback. Yeah, Omar Sedu Bashir, mathematical modeling from Nigeria. Great to see you again. And sorry once again, yesterday due to some technical issue, we have to postpone the session, and all of you have some inconvenience due to the postpone. We understand all these things. Yes. So now you can see my desktop, and you can see also my presentation. Both are perfectly visible. Please ensure me if everything is fine to you, so that we can start today's session. Our session will be on the introduction to the initial and boundary value problems with MATLAB. As we all know that these initial and boundary value problems play very important role to study various type of the mathematical model, not only in the mathematics but also the other branches of the science. In engineering, there are so many physical problems which are based on initial and boundary value problems, and also these will help us for the prediction. And there are so many mathematical model in all the basic sciences, biomedical science, in chemistry, in environment problem. Okay, so by using, we will start with a very brief introduction. Chris, great. Hello, hello, Chris. You are from Romania. Great. Nice to see you here. So today's session will be very interesting, and also please let me know if you are very beginner with MATLAB, or you already using MATLAB for your academia. So this will help me for support you, and I hope that MATLAB and this presentation both are visible to all of you. So if you have any question during the session, you can put your question in the chat box. Yes, nice, great. And once again, I'm very happy to see all of you. I'm waiting if some participant can join us. Right now we have about 11 participants have joined us. Great. Okay, many participants are from Nigeria. Let's start now and keep in touch with us during the entire session. What we do, we will try to introduce some with the help of the example, initial value problems and boundary value problems, and then our main focus will be how we can solve these problems by using some computing software. But as you know, this is the MATLAB series, and we will use MATLAB to solve this type of the problems. Actually, when we solve the initial value problems or boundary value problems by analytical methods, but there are so many problems which we are not able to find out their solution by using analytical method. We need approximation, and for that we have the numerical approach. Okay, there are so many numerical methods till now we have, and all the methods we are not able to cover during the session, but this session will help you to understand how we can integrate MATLAB for your academia. Ritik Kumar from India, and Ibrahim El Omar. Yes, you are from Morocco. Great to see you, and you are working on algebraic partial equations. Great. So this journey will help you many more for your academia. So this is a very simple definition. What is definition of initial value problem? Okay, so this is the just a basic concept. An initial value problem involves finding a function that satisfies a differential equation and meets specified values known as initial condition at a given point. These problems are common in various fields such as physics, engineering, biology, where the future state of a system is determined based on its current state. So when we need some prediction, so these type of the initial value problem will help us for the prediction. And here the very basic definition for the boundary value problem, which involve finding the function that satisfies a differential equation and meets specified values known as boundary conditions at the boundary of the domain. So in this case, in the interval, if you are given some specific domain at the initial and terminal, at both the point we are given some value of the function, and between these 2 points we have to find out all the values which are intermediate points. Okay, and boundary value problems are often encountered in steady state problems in engineering and physics, where conditions are specified at the extremes of domain, such as temperature distribution in road, which is the very simple example. And then how we can define the initial value problem, and all of you are very familiar about all this, but this is just an overview about the initial value problem and what are the boundary value problems. So this will help you to understand how we can integrate to solve this type of the problem by using MATLAB. Okay, so I hope all of you are very familiar about this. This topic is going to be very interesting, and MATLAB play a very important role to study this type of the problems and for the prediction and to find out the solutions of initial value problems and boundary value problems. So we are going to start with very definition of the initial value problem. So here we can consider the first order differential equation ODE, which is dy upon dt is equal to f(dy). This is the first order differential equation, and right hand side we have the function of only t and y. And here you can see that the initial condition we are given, and on the basis of this initial condition we can find out the solution of this dy upon dt at the desired value. Okay, but we have to start with the given condition. So here t is the independent variable, y is dependent variable, f dy is the given function, t0 is the initial point, okay, and y0 is the initial value of the dependent variable at t0. Okay, so from the given this information we can find out the solution of the desired time, okay, at the desired point. So here we have the example of the boundary value from, which you can see, and this will help us to understand. So here d2y upon dx square is equal to gx comma y comma dx dy upon dx, and we are given here the boundary conditions which are in the equation 4. Okay, here we have ya is equal to alpha. Sorry. So at the left boundary point we have the value of function is y is equal to alpha and yb is equal to beta. Means when we have the right boundary point, the function value of y we have is beta. So here these are some basic parameters which are involved in this boundary value problem, and this will help us to understand how we can solve the these initial value problem and boundary value problems by using MATLAB. So x is the independent variable, y is dependent variable, gx comma y dy upon dx is the given function which you can see on the right hand side of equation number 3. Okay, a and b, these are the boundary points. A and B, these are the boundary points, and as you can see here we have, yes, so here is we have is x is equal to a, and at this place we have x is equal to b, and these are the boundary values we are given. So ya we have is alpha and this value is yb. When x is equal to b, the value of y we have is beta. So these boundary values we are given, and we need to find out the values at the interior point, and by giving this information we can find out the solution of this type of the boundary value problems. Okay, but how the MATLAB will help you to find out the solutions of this type of the problems, and we will cover all these things one by one. And here you can see very simple example for the initial value problem. This is the just overview. You can see dy upon dt is equal to 3y plus 2t, and this is the initial condition. So we can easily find out the solution of this initial value problem by using the analytical approach. But this is the not our problem. Our problem is how we can integrate MATLAB to find out the solution of this type of the problem, and our main focus will be remain on computing part by using any software. So during this session we will use MATLAB, and by using the MATLAB we will find out the solutions of these type of the problems. Here is the example for boundary value problem d2y upon dx square is equal to minus y, and you can see here the values at the left boundary point. So here the interval is at this place x is equal to 0, and at this place we have is x is equal to pi. Okay, and this will be some type of the solution, maybe in this type. Okay, and the values at this point and at this point both are 0. And this place y is 0 and here is also y 0. So we need to find out the solution for this boundary from for these intermediate points. Okay, and this will help you to find out the solutions by using different type of the method. But here we will use some solvers which are inbuilt function in the MATLAB, and some of more examples I will try to demonstrate. More example according to the time which we have. Yes, so here numerical methods will help us for approximate solution using method like Euler method, Rakta method, and some more methods are there for the initial from. Okay, and here we have the Euler method. You can see we can use this method also, and which is completely we have the approximation method, and Euler method is a straightforward numerical approach to solve the initial value problem, and we can easily integrate, we can easily use this method, and with the help of MATLAB we can find out the solution of any kind of initial value problems. So here we have dy upon dt is equal to ft and this is the initial condition. So this is the Euler's upright method. What this will do, when we have an this is the equation, and by using this equation we can update the solution for the desired value. Okay, so when how this will work, when we have n equal to 0, this will be we have y1 is equal to y0 plus hf t0 and y0. So on the right hand side you can see that all the values are known. H will be the step size. H will be the step size. If you are given this is the initial value and this is the desired value at which you need to find out the solution, and we are given this interval. Okay, so what you will do, you will divide this in the sub interval. Okay, and this will be the step size. This will be x1, x2, x3 and so on. At the end we have this will be xn minus 1 and this will be the xn. Okay, so with the help of this step size we can easily find out this value by using this Euler method. Okay, and also this method is, and in this you can see T naught will be equal to T naught plus NH, where Yn is the approximation of Y8 Tn. Okay, so this is the just overview about the Euler method, and then this is the Euler improved method, which is also again help you to find out the solution. So Mehar method, also known as improved Euler methods, okay, refines the basic Euler approach by considering the slope at the beginning and end of the interval. So here what we have to do, we need to find out the value of k1 which will be equal to ft and yn. Okay, this will be the first slope, and then k2 will be equal to ftn plus h yn plus hk1. Okay, so if you have like in this way, so if you are taking this value, so slope at this point and slope at this point. Okay, so this value, this is the mean of the slope. This is the mean of these slopes. Okay, so k1 is dy upon dx, dy upon dt, and k2 is also dy upon dt, but at this point and at this point. Okay, so these both are the slope at for this interval, at these two endpoints, and then yn plus 1 will be updated by using yn plus h upon 2 k1 plus k2. Also in this method you can observe that the values on the right hand side are known and this is unknown. So from these known value, this part is known and this is unknown. Okay, so this unknown part can be computed with the help of the given information, and this is the improved Euler method we can use to find out the solution of by using computing or with the help of MATLAB, with the help of you can use also Python to find out the solution numerically. Okay, C programming is there also. Yes, and Rangita method is also very familiar to all of us to find out the solution. Okay, so here you can see if we are given dy upon dt is equal to ft by k1 will be equal to h ft and yn, and this is the given initial condition. We have to find out k2, then k3 and k4. So all these values are computed with the given values with the help of known values. Okay, all these are known, and with the help of known values we can compute all these value. And here on the right hand side you can see this part is known because k1, k2, k3, k4 and this value, all these are known, and from the known values on the left hand side we have unknown. We can find out the value of unknown from the given initial values. Okay, so this method we can easily implement in the MATLAB to find out the solution of the initial value prompts. And here we have MATLAB provides several functions for solving initial value prompts such as ODE 45, ODE 23, ODE 15s. So these three methods, these are the MATLAB inbuilt solver, and by using these MATLAB inbuilt solver, we can easily find out the solution of the initial value prompts. And these inbuilt solvers are based on these numerical method like Rangita, Euler method. Okay, by using these we can these solvers are created as a inbuilt solver. Okay, so you can see ODE 45 is based on the Rangita method, and ODE 23 is also based on Rangita method. Okay, and ODE 15, this is also the numerical differential formula. Okay, so these three methods, ODE 45 is a very versatile solver, and we can easily use everywhere. But sometimes if there is any kind of the strict type of the problem, in that case we can use ODE 15s. And one more thing I will let you know that the methods which are exist, we have to check which method can provide more accurate solution. Accuracy and error is also play very important role to find out the solution of this type of the problems. Okay, Ibrahim and Rahim, Sushil Kumar, Zahid, Priyanka, Deepa, and Rashid Javiu from Nigeria, from India. Great to see you again in this session. Yes. So there are many types of the problems of the which are based on initial value problem and boundary value problems. But for those problems, we have different type of the methods, and we have to use according to their efficiency, their capability, and how much they are providing us accurate solution. Error analysis is also play a very important role to find out the solutions by using approximation technique or numerical methods. Okay, so many things we need to find out the solutions of this type of the problems. So here we want to use, we have the simple ODE, dy upon dt is equal to minus 2y plus sin t. Okay, and we want to find out the solution of this initial value problem by using MATLAB. Okay, and this is the very first example. Just you need to follow the steps which I need to explain here. And one more thing I will recommend all of you. You must stay connected during the entire session. If you will skip any part, then this will create problem for you. So sometimes we have any WhatsApp message or call on our mobile. That will always interrupt the ongoing session. Okay, so always avoid to check the WhatsApp message or any emergency call. Okay, so when you are coming to join this session, always fix your time to attend the session, and so that these content may be very useful, very helpful to all of you. So now, how we can proceed to implement MATLAB? Here we are given, this is the initial value problem, dy upon dt is equal to minus 2y plus sin t. And this we are given the initial condition y0 is equal to 1. So what we have to do, we have to, these 4 steps will be involved in our MATLAB code. First we need to define the ODE function, then we have to set the initial condition, and after that, these 2 steps, we need to call ODE 45 solver, and you need to understand how we are using this ODE 45 to find out the solution. Okay, and then after we will plot and interpret the result. So these 4 steps will involve in our problem. So first you need to note this given initial value problem with initial condition. Okay, and now we are going to implement MATLAB. See here, this is the step-by-step equation you can see here, and we convert the given initial value problem, which is dy upon dt is equal to minus 2y plus sin t. This is the given initial condition, and y0 is equal to 1. So first we need to define ODE function. First we need to define ODE function. The green line is the commented line which will describe about the function, and the black syntax which you can see, these are the MATLAB syntax, MATLAB code. Okay, so here at the rate, this is the function handle we are using directly. Okay, at the rate, in this differential equation there are 2 variables, one is dependent and one is independent. So you can easily write this differential equation with the help of this at the rate by using the function handle, by using the anonymous function at the rate t comma y. Okay, and you can see on the right hand side minus 2y plus sin t and plus sin t. Okay, so this is the given differential equation which we write at this place, which we define at this place, and this right hand side will be stored at this place. This is the ODE function. ODE function means dy upon dt. As we know that dy upon dt is equal to fty. Okay, so this is the function. So the all the information which is on the right hand side will be stored in ODE. You can see this fty is equal to this one. Now this initial condition, we can easily set the initial condition y0 is equal to 1. Okay, so this is a given initial condition, which is very quite simple to write the code in MATLAB. Then after, what you will do, we will define the span. Time span we are choosing here 0 to 10. When we have t is equal to 0, y is equal to 1, and t is equal to 10, then what will be the value of y? Okay, so this is the initial condition, and this is the desired value. But here what we will do, we are using here ODE 45. How you can use this method? See, this is a MATLAB solver which is inbuilt in the MATLAB. Just you will call at this place, and then after first we need to we have 3 input arguments for this ODE solver. One is ODE function. You will put this at this place. Then we have t span, the input parameters. Then we have the initial condition. Okay, so in this order you will put all the input argument for this ODE solver. This ODE solver will solve all the values, and all the values will store at this place. T is the first one array, and y is the second array. T is the independent and y is dependent. Okay, 2 arrays will be generated by using all this. Then after that we need to plot this function, and for the plot we have plot ty. Okay, these statements are used here for the plot. Plot is inbuilt function in the MATLAB. We can call the plot function, and always use the independent variable first, then dependent variable. Then you can assign the x label. We have is time t. Then we have the y label. You can see solution y, and then after we can assign the title. Solution of dy upon dt is equal to minus 2y plus sin t. This is the title. So these are the sequence of statement. By using this sequence of statement, we can easily find out the solution of this initial value problem. Okay, see now in the MATLAB what MATLAB will do. See here, this is the MATLAB, and in the MATLAB we have, this is the problem. You can see the syntax which we discuss in the PPT will be same as in the MATLAB. Okay, so here this is the entire example which we save the file in the MATLAB with the example.m. See, the example.m, this is the file name, and this is the first example. Dy upon dx is equal to minus 2y sin t with initial condition y0 is equal to 1. Then we define the ODE function. This is the initial condition. This is the time span. Then we will call the ODE 45 and come to this place. Here, these statements which you can see are used to plot the graph. This will return the numerical graph. Okay, so plot t comma y. Then we assign the x label, and you can see the yellow part which is highlighted at this place. This is the x label on the horizontal line. Okay, if you want to assign the y label, then you can use solution y. This will be on the vertical line. Okay, and this yellow part which I highlight at this place, this will be the title of the image, and grid on. Okay, also I use 2 statements here also. This statement will return us the numerical values. Okay, and easy to use here. Num is only the assignment variable. Okay, is equal to t comma y, or either you can use space at space. Here is display num. So this is the entire script file which I created at this place, and just you need to run the entire code. Okay, if you want to get this entire this content, I will provide you. Okay, so when you will execute this sequence of statement, you can check again. Okay, and just play from this place. So when I will execute, you can find this is the solution of the given initial value problem. dy upon dt is equal to minus 2y plus sin t. Okay, and the maximum value, when you can see, when we have t is 0, the value of y is 1, you can see at the top at this place. Okay, so as soon as time will increase up to 10, the value of this function will become approximately minus 0 point something. Okay, and you can check also the numerical values which will be appeared on the command window. This is the command window, and here we have the numerical solution which you can see. In the first column, these are the values of t, and in the second column, these are the values of y. Okay. Is it clear? If you have any questions or any doubt related to this problem, you can put your question in the chat box. Yes, please. If you have any doubt related to this example, please let me know. And further, if you want to change, what you will do, you can manipulate. You have, if you have dy upon dt is equal to, we have at the place minus 2y plus cosine t. This is now another code, another differential equation. You can re-execute and you can see that we have new solution. This is the new solution. Okay, if you have at this place plus 2y plus cos t and again execute, you can see this is the, again we have new solution. Okay, if you have at this place, this is minus, and we are taking here cosine exponential. This is the exponential function. Now this has become new equation, and you can execute. Okay, so this is the solution of the differential equation, and as well you can check the numerical values which will be always appear on the command window. Okay, this part where my cursor is moving, this is the command window, and in the command window you can check the numerical values. Okay, so these are the numerical values. In the first column we have the t interval, and in the second we have the values of y corresponding to t. Okay, so in this way you can easily use this method. You can manipulate for different type of the problems, and again I am changing this value for sin t. Okay, and you can execute, you can check. This is the solution. If you want to save this file, very quite simple. You can press Control S, and then give the name figure 1. This is figure 1, and you need to use the extension. From this place you can select the extension. If you want to save in PNG, you can select this part. Okay, and if you want to save the file in JPG format, you can select this part. If you want to save the file in PDF, you can select this part. Mostly we are using JPG extension. I will select this one and save it. So this file will save automatically in my current directory. Okay. You can see at this page. The file automatically saved in my current directory, figure1.jpg. Okay. So in this way, we can create the script file. We can solve the initial value problem. If there is any question related to this example, please feel free. You can put your question in the chat box. I will try to reply you. If it is okay, reply me, yes, it is okay. 1 minute, please. Do immediately. If you have, this concept is very clear, reply me, okay. If you have doubt, put your question in the chat box. So if you have any question, please put your question in the chat box. Okay. So that if it is very clear, then you can put in the chat box, it is clear. So that this session can be interesting and useful for you. Yes. Many participants have joined with us now. Okay, so here you can see once again. So this example we have discussed very carefully. The plot shows the solution of the ODEs over the specified time span, and the function ODE 45 provides an accurate and efficient solution for this initial value problem. Now we have the second order partial differential equation. You can see here. Okay, so if we have the second order partial differential equation, then how we can find out the solution of this type of the problems? Now come here, we are given d2y upon dx square plus 3 dy upon dt plus 2y is equal to cos t. Okay, I got one question. One is not able to understand the interpretation of the graph. See here once again. Okay, see, this is the first example. Very simple. For the problem which is dy upon dt is equal to minus 2y plus sin t, and we were given that y0 is equal to 1. Okay, so from this condition, by using this initial condition, we find out the solution, and this is the graphical interpretation. Okay, so here in the graph you can observe that when at this place we have t is equal to 0, and at the place we have is t is equal to 10. So this is the interval. Okay, and this is the initial condition. When we have is t equal to 0, y is equal to 1. This is the one value. So this is the given initial condition. Okay, so by using this approach, we want to find out the solution which is known as initial condition, and we want to find out the solution when we have is t equal to 10, then what is the value of y? Okay, so this is the value of y when we have is t equal to 10. Okay, so when we apply our method, okay, by using the same, we have this graph and this is the desired value, and at the place we have is y0. You can see this is y0 and here is y0, and this is approximately minus 0. Approximately minus 0.1, approximately minus 0.1. Okay, so this is the added place we have minus 0.5. This is 0.1, 0.2, 0.3, 0.4 and 0.5. This is the approximately we have minus 0.1. So this is a very simple graphical interpretation, and these are the measures of vertical lines and horizontal line. These are the grids. Okay, and on the basis of this grid we can interpret the result. We can analyze the result, how the behavior of this differential equation. So as soon as the value of t is increasing, you can see the corresponding its solution. Okay. Is it clear now? Is it clear? So here we want to solve we have just 1 minute. Yes, now we want to discuss about this example, which is higher order. I hope the doubt is very clear. Yes. So here you can see we have d2y upon dt square plus 3 dy upon dt plus 2y is equal to cosine t, and along with we are given this initial condition. Okay, y0 is equal to 0 and dy upon dt at t equal to 0 is 1. So we are given two conditions. Okay, but both are the initial condition. The values we are given here, we have a t, and at its place the value of t is 0. So corresponding to this value y0 we are given 0 and y dash 0, which is the derivative of y, is given 1. Okay, so these initial condition we are given, and by using these we want to find out the solution of this second order differential equation, and by using the same, if we have the third equation, third order or fourth order, we can find out the solution of any higher order differential equations. Okay, but what will be the procedure to find out the solution by using computing approach? Okay, so the approach is very quite simple. Follow these 5 steps. First, we need to convert the second order differential equation to the system of first order. Note this point. So the second order, this part, we have to reduce in the system of first ODE. Then second step, define the system of ODE. This part is very important. Then we need to set the initial condition. Then we will call the ODE solver, ODE 45, and after that we will plot and analyze the result. So these 5 steps will involve to compute this value numerically. we note that we are not doing an analytical solution. We are using the MATLAB software to find out the solutions of initial value prompts and boundary value prompts by using computing approach. Okay, and most of the we are using here the inbuilt solver, and this will help you to understand how frequently we can easily visualize the solution of this type of the prompts. Okay, so now come to here how we can reduce the given differential equation into the first order differential equations. So here you can see we have to choose y1 is equal to y. Note this part very carefully. y1 is equal to y and y2 is equal to dy upon dt, and also I am writing again here d2y upon dt square plus 3 dy upon dt plus 2y is equal to cos t. This is the given second order differential equation. Okay, so here when you will choose y1 is equal to y and y2 is equal to dy upon dt, and you will see that this is the first order only, and this is the simple variable. Okay, so now d1, this is the system of the equations. So if this given differential equation will involve y2 d2y upon dt square, this expression can be written as dy1 upon dt is equal to y2. The meaning of this one is d2y upon dt square. Okay, so since y1 is since y1 is y, so this is the dy upon dt. This is dy upon dt and will be equal to y2. Okay, and now come to the given differential equation. What about dy2? See, this is the second order derivative, and we will write at this place dy2 upon dt will be equal to, on the right hand side we have is cosine t, this is the cosine t, and this is the plus 3 dy upon dt, but dy upon dt we have is y2, so this part will be minus 3 y2. Note this point, the second term of the differential equation. Once again I am clearing all this and see again. d2y upon dt square plus 3 dy upon dt plus 2y is equal to cos t. Okay, so here this is we have is only dy upon dt, and now we want to convert this equation into the first order. Okay, so here we have is d2y upon dt can be written as dy2 upon dt, dy2 upon dt, and the remaining part of these will be to the right hand side of this equation. So this is the cosine t we are writing at this place, and this term will be 3 dy upon dt on the right hand side minus 3 dy upon dt, but the value of dy upon dt is equal to y2. So this value will be used at this place, and hence it will reduce to 3y2 and 2y. The last term will be minus 2y1. So this is the our system of first order differential equations. So here this is dy1 upon dt and this is dy upon dt. So any higher order differential equation we can easily convert the equation into first order system of differential equations, and then this will help us to write the MATLAB code. So following the same we can use for higher order more than 2. So here you can see the entire code for the second order differential equation. So here we are defining the system. The process is same at the rate ty. We have now system of equation. So this is the y2 and this is the value of dy2 upon dt. This is dy upon dt, dy2 upon dt, dy2 upon dt, which is cos t minus 3 y2 minus 2 y1. Okay, so here we have to define the system of ODE. Then we have to set the initial condition, and these are the given initial conditions. Y0 we store at its place. Okay, when t equal to 0, this is the value of y and this is the value of y dash 0. Okay, so both the initial condition will be stored at this place, you can see. Then we have the t span. Okay, so we are taking the interval from 0 to 10. We want to find out the solution. These initial conditions we are given and we want to find out when t is equal to 10. You can manipulate this interval according to your desire. Good evening, Krishan, Sanju. Good evening, all of you. And today you go late to join the session. And once again, I feel very sorry. Yesterday we have to postpone the session due to some technical issue, but don't worry. Now you are with us. Okay. So you can see when you define the system of equation, you set the initial condition, you define the time span, then we will use ODE 45, and these are the input argument. First we will use ODE system, then we have the t span, and at this place we have the initial conditions. So the pattern of the argument will remain same. Note this point very carefully. After that, we need to find out the solution, but here we will find out two solutions. One is y1 and one is y2. Okay, y1 is corresponding to y and y2 is corresponding to dy upon dt. So we choose y1 is equal to y and y2 is equal to y dash. Okay, so here we have two solutions and both will be written at a place. So this is the syntax. See, plot t y colon 1. This is the solution for this one, for y. And here t comma y colon 2. This is corresponding to the second, which is y dash dy upon dt. So here we will find out the two values. One is corresponding to y, second corresponding to y dash. Okay, you can assign x label, y label, and title. So this is the entire syntax in the MATLAB code, and the same we have used in MATLAB. Okay, so now you can see the MATLAB code. This is the same as we discussed in the presentation. Here we define here the system of equations which we define. Okay, then we have the initial condition, then we have the time span, then we have using the ODE 45 to find out the solution of the system of ODEs. Okay, and these statements are same for the visualization of our result. Along with we are using here one more statement, which is less than. Less than is used because here we have two equations, two solutions. One is the value of y, and second is value of dy upon dt. Okay, so both will be visualized in our graph, and then we have grid on, and also we visualize the numerical values, and display function will return numerical values in the desktop. Okay. Yes. So now this is the entire code. You can see the top. And the green part, green equations which you can see here, these are the commented, and this is the equation. These are the condition which we are given. Okay. So now when you will execute this sequence of statement, you can say we have the solution, and you can easily interpret now. You can yourself interpret the solution. Check it. Check the graph very carefully. On the horizontal line, we have a time. On the horizontal line, we have a time. Okay, you can see this is time, and we choose the interval from 0 to 10. So, and this is the initial value. When t is 0, y is 0, y dash is 1. Okay, so here you can see this is y. The graph in blue color, this is y. Here you can see y1. y1 is equal to, we have is y, and y2 we have is dy upon dt. Okay, y2 is dy upon dt. So you can see the value of dy upon dt when t is 0, we have is 1. So these two conditions are given to us. Okay, so in the blue color you can find out our desired solution. Okay, so this is the behavior of the differential equation. When you will find out the solution of the differential equation, the dynamic equation will move according to this graph. Okay, so when we have t is equal to 10, when we have t is equal to 10, this is the value of y. See the blue line, this is the value of y, which is approximately minus 0.2 something. Okay, here we have is 2, and here is we have is 0.3, minus 0.3. Okay, so the value of y will be minus 0.2 something. And also you can see the graph which is in the orange color. Okay, this graph is used for dy upon dt. Okay, the graph will move according to this one. Okay, so both the graph are visualized and displayed by using the single statement, along with if you need the numerical values, because the numerical values are also required, and you can see in the command window all the numerical values will appear in the command window. Yes, very smartly the solutions are appeared at place. So what is inside? In the first column, these are the value of t, 0 to 10. Next value is 10. You can see 0 to 10. Okay. Second column is the values of y, and third column are the values of dy upon dt. And you can say dy upon dt is 1 when t is 0. Okay, and when we have t is equal to 10, the value of y is minus 0.2471, and that of dy upon dt we have is minus 0.1973. Okay, so these values are corresponding to the values of t, and numerical solution also you can see in the command window, and the graphical expression also you have. Again, check it. Yes. So this is the graph. If you want to manipulate the interval, suppose I have the interval is from 0 to 5. So now you can see the graph is in the interval from 0 to 5. Okay, we have 0 to 5, but the initial conditions on the left hand side are same. These will not change. If you want to make more small, I want to find out 0 to 1. Yes, so this is a graph in the interval from 0 to 1. You can manipulate easily. Once you will write the MATLAB code, you can play, you can do different type of experiment. And also, if you want to change the differential equation, suppose that at the place of cosine, I have at the place sine t. I have a sine function. Now this is new differential equation, and you can have new solution. This is the another solution. Okay, and if I have the interval is 0 to 10. Yes. Oh, sorry, this is the interval. This is the interval. Okay, time span. We need to change the time span. Yes, now you can see. Okay, and if you increase up to 100, so this will be like in this way. This will appear like in this way. So this is the graph from 0 to 100. So once you write the code in MATLAB, you can do different type of the experiment. Okay, as much as large. If you will make address space 200, okay, and you can see the graph will appear like in this way. The interval is from 0 to 200. Okay, so by changing these values, you can easily manipulate. You can do different type of experiment. Here is cosine t, right? This is cosine t. The actual statement we are given here is cosine. You can check it. Okay. So once you write the MATLAB code, you can do various type of experiment. You can check the behavior of the given governing equation, and this will help us for the prediction. How this will help to predict the value? You can see we are given only the initial condition when we have t is 0. Okay, and we can easily get the value when t is 20. Okay, that's why these initial conditions, initial values are very helpful for the different type to solve different type of the dynamic problems which are associated with physical science, biology, engineering problems, and many more. Okay, so now we will discuss about some boundary. Is there any question, please? Please let me know if you have any question, any doubt related to this example. If you don't have any problem, we can go for the next example. Okay. So dear participant, we present here two examples. One is simple, just only first order differential equation. Then we choose higher order higher order differential equation. Okay, we choose here second order, but you can manipulate for the higher order more than two, for third order, for fourth order, and any order you can use. But beyond these two methods, we are using here ODE 45. There are so many methods which you can. Okay, so now if you have any question, any doubt, please put in the chat box so that I can reply your question. Okay, and yes, please put your question in the chat box. I am checking the chat box also parallelly. Thank you. I think there is no doubt. You are making sense, sir. Thank you for your reply. Sally Most. How are you today? I think you got late. Okay, you joined the session in the beginning. Great. So now come to next example. So here what was in this example, the plot shows the solutions y1 and y2 over the specified time span. Y1 represents the solution y and y2 represents the derivative. Okay. So this is all about the initial value problem and boundary value problems. Understanding the initial value problem and boundary value problem is fundamental in the study of differential equation. These problems are initial in modeling and solving real world phenomena across various scientific and engineering disciplines. The mathematical formulation and examples provided give a functional understanding of how to approach and solve these problems using both analytical and numerical solutions. Okay, so these are the demonstration, and by using the MATLAB, how we can solve different type of the initial value problems and boundary value problems. Okay, so now dear participants, this is all about the today's session, and in the coming Sunday we will cover some interesting sessions. So the main thing is, all the participants who are attending this session, you must recommend these live sessions to your colleagues, to your students, to your friends, so that they can also get some knowledge. And also your motivation is very important for us. I will provide you the feedback link in the description. You will find after few minutes. So your feedback is also very important. Along with that, if you have any question which you want to see in the coming session, or you want to solve, you want to find some solutions of your problems, you must put in the feedback form, and after over the session you will find, after about 15 minutes, you will find the feedback form in the description and submit there. Okay, and also I will share the feedback form in the our webinar group also. We have webinar WhatsApp group. And one more thing, if you did not subscribe my channel, you must subscribe. This will help us. And also the certificate of participation will be provided you if you will submit the feedback form. Only then you will get the certificate of participation of each webinar. So this is all about today's session. And in the coming session, I will update you, and the topic will be announced by tomorrow. So thank you very much to see this lecture till the end. Now we are going to end the session. Thank you very much. Stay connected and enjoy the sessions. But don't forget to share this information with your student, with your colleague, and also you should like the channel for the promotion of the session. Okay.